So impulse will be the area underneath that curve. So when they give you an area like this, they'll say this is time, this is force. The force looked like that. What would you do?
Half of base times height.
Yeah. So you find the area of this triangle using 1/2 base times the height. And that'll give you your impulse. That'll give you the area of that triangle. So that would be J. Then what if it asked you to find the average force over that time? So that would be saying...
You just divide it by however, yeah, the length of it.
Yeah, you divide it by your time, exactly. And that'll give you an average force up here. And if you plotted it out, it'll be the same area as under the triangle. Okay. Do you want to try it? Let's try like an example of that. Well, real quick, let's talk about momentum, like bar charts. So sometimes what they'll do, an easy way to keep track of momentum and that kind of thing, is to draw a little bar chart. So say you started out with a momentum of like 3 meters per second, a mass of 2 kilograms. And then there was an impulse of 10 kilogram meters per second. And it said find its final momentum. So what you could do is say, well, what's our initial momentum?
6.
So you started at 6. So this is px initial. What's our impulse?
-10.
Yep. So then you draw this. So -10, that's your J. What would your final momentum be?
-4.
Right. Let's start here. So this would be px2, -4. That's how they use momentum bar charts. Just basically showing it graphically so you can kind of keep track of it. You don't have to do that every time. Sometimes it'll ask you to, but it's not necessary every time.
Which is exactly what these are.
Yeah, exactly. So if this was a +10, we would have done the same thing, except we would have drawn this up. Then we would have added the 2, right? It would have been like that. So they're pretty easy to use. Okay.
So this is kind of our free body motion or free diagram.
Yeah, sorta, kinda. So let's look at that example. So 100 gram rubber ball is dropped from a height of 2 meters onto a hard floor. Figure 9.10 shows the force that the floor exerts on the ball. How high does the ball bounce? So, that's the other thing. When you do impulse and momentum, you're only looking at either side of the collision, right? So if you have something, in this problem, you've got a ball, and it's 100 grams, dropped from 2 meters. It hits the ground, then it bounces back to a certain height over here. Okay? So when you try to find the momentum beforehand, what point do you want to do it at? Like the momentum before the collision.
Right before it hits the ground?
Yeah, it's right there. And then the momentum after it hits the collision, or after the collision?
Or right after it loses contact?
Yeah. So you'll do a before and after. That's kind of how you'll solve these problems. Okay. So what would the velocity be right before it hits the ground? It's a kinetics problem. So we could say velocity in y final squared equals velocity in y initial squared plus 2 times 9.8, because that's acceleration. Negative 9.8. Oh, wait. Oh, times delta y, which is negative 2. That makes sense?
And 100?
What's that?
The 100.
Oh, so this is just a kinetics. This is v final squared equals v initial squared plus 2a delta y. So we don't need to worry about the 100 grams yet. We're just trying to find a velocity.
Okay.
So this would be 4 times 9.8 is 39.2.
Very close.
So velocity y final squared equals 39.2. So whatever the square root of 39.2 is, that's your velocity right before it hits the ground, right? So this is square root 39.2 meters per second.
See, we have joules in some of these problems.
Let's see. There's a joule. Let's see.
Is this the right assignment, you think?
Yeah, it is. Talking about impulse momentum. I think, is a joule a kilogram meter per second? No. So.
And it talks, what is I?
That's a vector.
Okay.
So 4i plus, is it 4i minus 3j? Negative 4i minus, or plus 3j? So that would mean you'd go negative 4 in the x direction, and then 3 in the y direction. So that's his velocity right there. But it's more useful if it's already broken into component form. Got it.
So to find our after now, for this ball, we're going to use our 100 grams now?
Yeah. So what would be the momentum right there?
Um, 100 times the square root of 39.2.
Mm-hmm. Do we want to use 100?
We'll actually probably convert it to kilograms, so 0.01.
It's just 0.1.
0.1.
Yeah.
Okay.
So MV and will that be positive or negative?